Hello everyone, my name is Hossein Tutunchi and welcome to MathLAB programming course. Today we're going to learn more about a special set of matrices in MathLAB known as special matrices. And they're called special because they do have specific use in engineering. The first one, which is frequently used, is zeros. So the way to create matrix zeros, and you can guess what it does, it asks for a number. Let me put 2. And if I do that, it creates a 2 by 2 matrix which all of its elements are 0. And we can easily create 5 by 5, or even bigger. And one of the use of these, when you wanted to create a big matrix and there are only certain elements of this matrix is going to be filled, it's better to create a zeros like this one. Let me create one like that, 7 by 7. And then let me actually put a name for it. Let me put it A0 7. And now if I come to here and double click on it, I do have the values here. For example, I wanted to create a new value for it. How about here? 1, 43, -6. So by doing that, if I call the matrix A, now it is the revised value just appears, and you can tell that by doing so you can create the desired matrix much faster. Let me clear the screen. Another important function that we use a lot is ones. So ones, and again it requires for a number, so we put 2. Unlike the zeros, which only creates the 0 values, it will create ones. So I put ones 5, and so a matrix will be created. You might be asking that, is it always going to be the square matrices? And the answer is no. You can create zeros of 3 and 4, which is perfectly fine, or ones of 2 and 5, which is again 5. Let me clear the screen. Another special matrix that we need to know is a diagonal matrix. One specific matrix is very well known in engineering field, and it is called the identity matrix. The way that we create identity matrix in MathLAB is through a function called I. If I put I and MathLAB asks for a number, I can put 4, and look what happens. If I do that, a matrix will be created which first of all is a square matrix, and second of all the diagonal elements are 1 and all the other ones are 0. This is the definition of the identity matrix. Similar to ones and zeros, I matrix can also be different than a square matrix like this one. So if I do that, you see that MathLAB tries to create the I matrix as long as possible, because this is the definition of the matrix A. But because it's not a square matrix, MathLAB is not able to create it, to make it a square. We can also put it like that, and you see that MathLAB just tries to create a matrix as close as possible to identity. Let me clear the screen. One specific characteristic of the identity matrix is that when it's multiplied to any matrix, the result is going to be that matrix, the original one. Let me show how does it work. So if I have, let's see what's A, it's a big one, let's go with B. Okay, so we do have a matrix B, and if I multiply it by I, so B multiplied by I of 4, you see that the dimensions does not agree. And it's very important to note that even special functions like I should match in dimension. So what is the dimension of B? The dimension of B is 2 by 3. So if we can create an identity matrix which is 3 by any number, we're able to do the multiplication. So let's create one. I have 3 and let's go 5. How about that? So it creates this matrix, and now if I multiply B multiplied by I, 3 and 5, you see that now the multiplication is possible. But the dimension of the result is not the dimension of the B, because the B matrix is this one. But now we do have 2 additional columns. The reason being is that we're only able to claim that the result is going to be the original matrix when the identity matrix is a square. So let me clear that. If I do have a matrix called B, which is a 3 by 3 matrix, like that, and I create an identity matrix called let's make it 3 by 3, like that, and if I multiply B to I, multiply them together, you see that the result is going to be matrix B. The original matrix is always true. So if you multiply any matrix with identity matrix which is a squared one, the result is going to be always the original matrix. Let me clear the screen. Another matrix that I would like to introduce to you is the magic matrix. So the magic, it just receives one number, and I put 3 here. So if I do that, magic 3, and I hit enter, you see that a new matrix is created, which is 3 by 3. And what is the magic number? Let's ask MathLAB. So if you search that, the magic returns an n by n matrix constructed from the integers 1 through n squared with equal row and column sums. Equal row and column sums. So what is the magic is that if you add the row elements and the column elements of this matrix, the result is going to be the same. Let's try that. What is the sum of the first row? Therefore, if we add 8 plus 1 plus 6, the result is going to be 15. Let's try this one. 8 plus 3, 11 plus 4, it is 15. How about the second one? So 1 plus 5 plus 9 is 15. And this one, 4 plus 9 plus 2 is also 15. Therefore, the summation of all elements in this matrix, therefore the summation of the rows and columns of this matrix for any specific rows and any specific column in this matrix is going to be a same number. It's called the magic number. There are also other special matrices which are not frequently used, so I leave them to you. So if you like, you can search the MathLAB for special matrices, and there are a couple more that you can explore.